Right, let's have a look at the question. The curve crosses the x-axis at the point A. That's here. Verify that the x-coordinate of A is 4. Verify means just to show that x equals 4 at y equals 0. So all we literally need to do is substitute 4 in to our curve, and we know that it is at y equals 0 at this point. So if it equals 0, then we can verify that the x-coordinate of A is 4. That is done. Now line L1 is tangent to the curve at A, so this is a tangent. It says use calculus to show that the equation of line L1 is like so. So calculus means we do dy dx. So remember, we multiply by the power and then decrease the power by 1. So our next bit will be dy dx equals 8 minus 5 over 2x to the power 3 over 2. And to find the gradient at this point, the gradient of the tangent at x equals 4, we just substitute x equals 4 here, because this dy dx is the gradient function. So let's substitute x equals 4 into your equation, and then you will get dy dx equals minus 12. Now I'm using y equals mx plus c because I know you prefer that. So at x equals 4, and we know y equals 0 at this point, we'll get 0 equals minus 12x plus c. Now let's substitute x equals 4 to this point. Right, so when we get c equals 48, we can rearrange the formula to get our y minus 12x plus 48 and rearrange it like they've asked. Now part C says the line L2 has equation 8x. This is L2, and we need to find the region R shaded in figure 3, which is here. That's our region, and it's bounded by the curve L1, by the line L1 and the line L2. Use algebraic integration to find the exact area of R. Well, one step is can you see, to find R we need to find this area of this whole triangle made by L1 and L2. Now we're going to need this value of this spot here to get the height of the triangle, aren't we? And we're going to need the width, which we can see is 4. So how can we find this equation, this spot? We know y equals 8x, and we have the equation of the line L1, so we set them to be equal to each other. Now let L1 equal L2, that's the spot here. That will give us the height eventually, and I'll show you how in a minute. Once we solve for 8x equals 48 minus 12x, rearrange to get 28x equals 48. So divide by 20, x equals 2.4. So when we get our x equals 2.4, we can substitute that 2.4 into any one of our equations to get our height of 19.2. Alright, and obviously the area of that triangle is therefore going to be 19.2 times the 4 divided by 2, get 38.4. Our next part is to subtract the region here from the triangle, which is bounded between 0 and 4, hence we will have a 4 and 0 here. Right, to integrate in respect to the x, remember we increase the power by 1 and then divide by the new power, and we'll get 4x squared minus 2 over 7x to the power 7 over 2. Okay, so what we're doing is 38.4 for our area minus the region bounded by this integration. Okay, once we work that out, we get 384.5 and we get our answer. Now here's a goal level question for you to try. Press pause and then give it a go. here's part 2, just to give that a practice. Think about the skills are the same. I'm going to show you the answers now. So you've got a turning point. The turning point is going to be at dy dx equals 0 when x equals 2. So that's here. So we dy dx, set it to 0, let x equals 2, and we solve for k equals 28. Part B, use calculus to find the exact area of R. Think about what it's going to be. You've got to have that height there that we need to find, because it's going to make a rectangle. So use our equation, original equation, which is here. Let's substitute your x equals 2 in. So our y coordinate at that point is going to be 24, so that's going to give us a height of 24, which you can see here, which is the y coordinate of P. And then we know x equals 2 because it's in the question. So we've got an area of a rectangle, 2 times 24, it's going to be 48. Now we need to minus, to get R, we need to minus the area underneath the curve from the rectangle to get R. So that's what we need to subtract. So that ranges between 0 and 2, so we integrate. Remember, increase by the power by 1, then divided by the new power. Do each step in turn. Make our region between 2 and 0, sub it incorrectly into your calculator. We get 100 over 3. And so the area of R equals 48 minus 100 over 3. And the answer is 44 over 3. That's an easy marks if you can remember how to do this. Right, let's look at this question. It's a geometric sequence, so remember to use geometric formulas in the formula book. Look at this pattern. That's A, AR, AR squared. What can we do? So the ratio between the second term divided by the first term must equal this term divided by this term. Right, and then we can simplify that by matching powers. That will probably be the easiest. So make that 3 squared times 7 minus 2k, and make that 3 squared times 7 minus 2k here, like so. Okay, now remember our rules of indices. If our bases are the same, we can just subtract the powers because these are division. So let's just minus powers using our algebra skills. So I've expanded the top and expanded both sides just to make our calculators easier. So remember, we just need to minus this by this. Just remember, a mistake here would be when we were subtracting here in this bracket, a minus and a minus becomes a plus. So we're going to get a plus 5 here. Same on this other side. This is how we're dividing the powers. Minus and a minus is going to get a plus 4k, but that will be minus 14. So we simplify. That gets us to 3 minus 8k plus 19 to 3 to the power 6k minus 16. So this must mean that this must equal this, and we can just set them equal to each other and solve it like so. So 35, once we simplified it, equals 14k divided by 14, so k equals 5 over 2. Once you spot that, this is a very easy question. And it says, hence find the sum to infinity of the geometric sequence. Well, now that we know k, we can sub that into our sequence to the power 4 times 5 over 2 minus 5. That's our first term. So that equals 243. Now we've got k, we can find a second term and a third term, because that's AR, and that's AR squared. And we know our second term is 81 and the third term is 27. So like I said before, we've got A, AR, and it's AR squared. So we're multiplying by R each time. and so we can see it's divided by 3, it's times a third. Now there's another way you can work out r by using your value for k, substituting it into both of these, and if you think about it, AR divided by A would be left with R, and what answer you get would be give you the ratio as well, so you could do it that way. So use the sum to infinity formula. Maybe you could have written this down first so that you know to find A and R. So that's our sum to infinity, write that down, substitute your A, substitute your R, work out the value, and that's easy 3 out of 3 marks. Now here's a question for you to try on your own. Make sure you can get that skill. Pause the video, give it a go. Now I'm going to go through it. Remember from before, you've got A, AR, AR squared. Set your ratios up. This divided by this equals this term divided by this term. Set equal to each other and expand and rearrange, and then you'll get that answer like it once you've shown that 4 out of 4. Part B, k is not an integer, show that k equals 9 over 11, so you just need to factorise and solve. You're going to get a solution of 11 obviously here, but it's not an integer, so that must mean it's this solution, which is of course 9 over 11, so you've shown that. Now for part C, the fourth term is AR cubed. We know k equals 9 over 11. So to find out A, we can just substitute it into here, a value for k. And this is what we're using. So A equals 8 over 11. And then we can use this term divided by this term. Because AR divided by A will leave us with R. Substitute our values for k in, and we get R equals minus 4. So that means our AR cubed is this answer here, which leaves us with minus 512 over 11, which is the correct answer, and we have done that question. Well done. And that's the value of the fourth term. Part 2, evaluate the sum of the first 10 terms. So we use the sum formula for a geometric sequence, which is like so. Substitute our A and R in. Do this correctly on the calculator with your brackets. There should be actually a bracket over the minus 4 here. I've missed that out, and that is our final answer. Good work. Right, let's look at the first kind of proof question that was in your paper. Show that k squared minus 4k plus 5 is positive for all real values of k. But it's a quadratic, so we can complete the square with this. Alright, complete the square. Get to k minus 2 squared plus 1. This statement is really important, where we know that k minus 2 squared is either going to be 0 or greater than 0. You must have this statement in the mark scheme. If you just write greater than 0, you don't get the mark. Because it's a proof, you do need to have some communication. And from this stage, you just need to write, so k squared minus 4x plus 5 is always positive, because it's a bit of an axiom. If this is 0 or greater and you add 1 to it, it's going to be positive. Part 2. A student was asked to prove by contradiction that there are no positive integers x and y such as this equals 28. Look at these two brackets. So that's a good starting statement to prove by contradiction. It's all defactorised, so think about your factors that can make 28. So this student has selected 14 and 2, so make this bracket 14, this bracket 2, solve simultaneously to get essentially answers as not integers. So all you need to do here is actually, this is easier question than normal, just complete the proof and add statement. So what other factors of 28 can you get? So look at your factors pairs of 28 to make 28. 2 and 14 is already done. You could actually try 2 here and 14 here instead to get a mark. But let's look at the actual different unique numbers we can have. It's 1 times 28, 4 times 7, minus 4 times 7, and minus 1 times minus 28. So all we need to do here is a simultaneous equations, and we can get 4 out of 4, which you're very good at. So here's our example. Set your 3x plus 2y equals 1. So this is this. So we set our second bracket to equal 28. Solve simultaneously. Make a coefficient equal, and I've made the x's equal, they're positive, so I subtract them. Be careful with your subtraction. Subtract and subtract makes a plus. So we get 19y equals minus 82. We can see these are not integers and not even positive. So you write your statement not integers and one of them is not positive. Good, we've done one pair, that's got another mark. You need to do all the 4 remaining pairs. So we've selected here 4 and 7 to see if it makes 28. You can see here, just rearrange so that we can cancel out a coefficient of x here. We get to 19y equals minus 13. So y equals minus 13 over 19. Sub that into any one of our formulas above, here or here. We get x equals 34 over 19. Again, not positive and not integers. So we've got 3 out of 4 there pretty much. Essentially all you need to do is do the other sets of factors I've shown you above, like here and here. Again, show that they're not integers or not positive, and then that completes your proof for 4 out of 4 marks. That's quite easily done. And that's essentially what I've just said. That's all you need to do, and that could be 4 out of 4 marks. I do think you can do this, you just wasn't aware of what you needed to do, which was the skill of getting those 4 marks. So let's go back to this question we showed you in class a while back. This is 4 marks. Prove by contradiction that there are no positive integers p and q, such as this is here. So we've had the skill, of course we forget, and you was able to do this once I showed you the start. You're all very good at making the starting statement. Spot the differences of 2 squares here. Set up your contradiction. There are positive integers such that this factorise equals 25. If true, then we can set up our factor pairs that this will be 5 and that will be 5 equals 25, and we can have 25 and 1. Because it says positive here, we don't need to use negative numbers as such. So that's very good, we can do that, and hopefully that makes sense. Obviously you should have paused this video and give this a go yourselves. So like the last question, all we need to do is set these 2 and solve simultaneously. Okay, solve, we get 4p equals 10 and p equals 2.5, which leaves us with q equals 0, and we can say, or the other option is here, solve simultaneously. We're going to get p equals 6.5 and q equals 12. This is an integer, but this isn't. Neither of these are really, 2.5 is not an integer either. So you can write there is contradiction, as there are no integer solutions, hence there are no positive integers such that 4p squared minus q squared equals 25. That is our statement to get our final mark that we must write down like so, because proofs require some communication. Right, well done if you got that, and that means we can now get some marks with proof by contradiction.